over 2. Okay. Evaluate. Again, I have no idea how to find the antiderivative of this yet. So the only thing I can do is do the area under the curve. Okay. This is the circle, the bottom part of the circle with radius 3. The 9 means that I'm going to move it up 9. So this would have been the original circle of radius 3. Okay. Here's my center. What this means is move the center up 9. Okay. So now it's still going to have a radius of 3. So it's going to look like this. The area under the curve is this part. Okay, so that is what I'm looking for that area under the curve. Sorry, my picture isn't the greatest. So what I'm going to do is I'm going to find the area of this rectangle and then subtract the area of the circle. Okay. So the area of the rectangle has a base of 6 and a height of 9. So that is going to be 54. The area of the circle, again, is pi r squared divided by 2 because it's only half a circle. So it's going to be pi times the radius squared over 2. So it'll be 54 minus 9 pi over 4. Okay, 15. The rate at which water flows out of a pipe is given by a differential function r of t. The table below shows the rate of 4 hours intervals for a 24-hour period. Use the right rectangular approximation with 6 subdivisions. That means I'm going to have 6 rectangles to approximate the area under the curve from 0 to 24. Okay, so let's draw this to give us an idea of what it's going to look like. 9.6, 10.3, 10.9, so here's my curve. So we're going to use right rectangular approximation. So that means the right hand of the graph or of the rectangle is going to touch the graph. Okay. So my first area is going to be 4, which is my base, and the height is 10.3. Second one is going to be, again, the base is 4. The base is 4, and the height is 10.9. Again, the base is 4 and 11.1. Base is 4, 10.9 is the height. Again, the base is 4, the height is 10.5. And the last one, the base is 4, and the height is 9.6. Okay, so if you add all of those together, you should get 253.20 gallons. And then the second question asks, explain the meaning of your answers in terms of the water flow. Okay, since this is the rate the water flows out of the pipe, okay, so what it means is from 0 in a 24-hour time period, 253.2 gallons flowed out of the pipe. So that's what it means, that 253.2 gallons went out of the pipe in a 24-hour period. 16, a particle moves along the coordinate axis. Its position is given by, okay, so there's my position. That's my antiderivative, where v is the velocity shown below. What is the particle position at t equals 0? Okay, so the particle position at t equals 0 well, remember that this means area under the curve. So if it started at 0 and I end at 0, I didn't go anywhere. So it would be 0. Second one, from 0 to 3. So this means find the area under the curve from 0 to 3. So from 0 to 3. So we basically have two triangles. First one has a base of 2 and a height of 2 and a base of 2. And it's going to be negative because it's below the x-axis. Second one has the base of 1 and a height of 1. So we're going to have negative 2 plus a half, which is negative 1 and 1/2. Okay. So that means that the particle was going to the left or down from where it started from. Okay, part C says, what is the particle's velocity at t equals 4? Well, this is the graph of the velocity. So at t equals 4, the velocity was 3. The trick question. Okay, number 17. The zoo sponsored a one-day contest to name a new baby elephant. The zoo visitors deposited entries in a special box between t equals 0 and t equals 8, so from between noon and 8 p.m. The number of entries per hour deposited into the box is shown in the table. So to use the left Riemann sub with 4 subintervals to approximate the integral from 0 to 8, okay, and explain the meaning. So we're going to graph this a little bit, kind of sketch it to give us an idea of what the graph is going to look like. Your sketch doesn't have to be exact. So this is what my graph will look like. So we're going to use the left Riemann sum. So the left side is going to touch the graph. So the first rectangle is going to have a height of 10 and a base of 1. Okay. Second rectangle is going to have a height of 30 and a base of 1. Okay. Third rectangle is going to have a height of 34 and a base of 2. And then the last one is going to have a height of 21 and a base of 3. So if you add these all together, you get 167 entries. And then the second question asks, what does that mean in the context of the problem? So what it means in the from noon to 8, about 167 entries were deposited into the box. Okay. So 167 entries were deposited into the box. Last one, number 18, is just finding the antiderivative of each individual one. So 3 is the coefficient, so I'm just going to bring it down. The antiderivative of cosine would be positive sine of x. And don't forget your plus c. Again, 5 is the coefficient, and the antiderivative of 1 over x is the ln of x. Proceed. So we're going to add 1, divide by the new coefficient. Okay, the antiderivative of sine of x is negative cosine of x. That's going to give me positive cosine. And then the antiderivative of e to the x, e to the x. Okay, the antiderivative of secant squared is tangent of x. Okay, things that we just have to know. For e, I would have to do a little bit of algebra to find it. So I'm going to distribute the x to the 1/2. So I'm going to have x to the 5/2 minus 2x to the 3/2. Okay, so I'm going to add 1. So I'm going to get x to the 7/2 divided by the new exponent or multiplied by the coefficient. Okay, then I'm going to have, again, 2 is a coefficient, so I'm going to bring it down. So I'm going to add 1. So I'm going to get x to the 5/2 times the reciprocal. So I'm going to have 2/7 x to the 7/2 minus 4 over 5 x to the 5/2 plus